Welcome to standard error of a regression line. The idea here is our regression line makes predictions, but we know our scatter plot doesn't always, our actual data doesn't always fall right on a regression line. And so we want an idea of sort of what is the typical error between the prediction and what actually happens. So we want the typical error between the regression line's prediction and what actually happened. So if we think of our scatter plot, and a regression line, then each point has an error from what the line would have predicted. So the distance from the line straight up or straight down to the point. These are all the errors. And we just want to find the standard deviation of those errors. So we would basically make a list of all the errors and then find the standard deviation. So each of these is an error. And we want the standard deviation. So standard error is simply the standard deviation of the errors. So when we talked about standard deviation, we talked about how it was essentially the standard or typical distance from the mean. So here it's measuring the typical distance from the regression line's prediction. So the standard error gives the typical distance from the regression line's prediction. So typical y values will fall in between the prediction and then plus or minus the standard error. So we'll do an example of this. We're back to our rain versus commute time. The study was run on the relationship between the inches of rain the previous night and my commute time to work in minutes. There is found to be a linear relationship with the regression line y equals 34 plus 31x, correlation coefficient r equals 0.51, and standard error s equals 9.4. So once again, key, we have a linear relationship. The line is going to give us our predictions. well, specifically the y value from the line will give us our predictions. And this is our standard error. So this is our plus or minus 9.4 is our wiggle room. So instead of giving a specific prediction, we can give a interval of prediction, or give ourselves some wiggle room. So for example, if we wanted to find the typical interval of commute times, so a typical commute time when there has been let's say 1 inch of rain, our base prediction we would just plug in x equals 1. So we have y is 34 plus 31 times 1. And that just winds up being 65. So our base prediction is 65 minutes. With wiggle room, we will now do that 65 plus or minus our 9.4 minutes. So what this means is we could drop down to 55.6. That's 65 minus 9.4. And then we could go up to 74.4 minutes. So we're just giving ourselves some wiggle room. We're not limiting ourselves to one guess when the line doesn't actually fit the exact points. So this gives ourselves a little more wiggle room for error. So that's the standard error.